What's up, everyone? The product rule. In this video, we're going to show you a new rule to help you find the derivative of some slightly more complicated problems. And to find that derivative, we're going to use something called the product rule. Now, when the heck do you use the product rule? Well, if you have a function that can be viewed as two functions being multiplied, use the product rule. So some examples of this. So look at this function here. We have 3x plus 2 times 4x squared minus 7x. So we have the product of two, you could view this as two individual functions. We got 3x plus 2 times 4x squared minus 7x. This is a good place where you'd want to use the product rule. Here's another example. We have 5x squared times sine of x. So we kind of have two different functions. 5x squared multiplied by sine of x. Another great place you'd use the product rule. And one more example here is the square root of x cubed times 3x squared minus 5x. Another place where we have two, it's one function, but it looks like it's two functions being multiplied. So again, product means multiplication, right? So when you have two functions being multiplied to create one function, that's a great place that you'd want to use the product rule. Now, one way that I like to use to explain this rule is to label the two functions u and v. So for example, you label the first function u, the second function v. So that means you could look at this as u times v, where u is 3x plus 2 and v is 4x squared minus 7x. Now, you don't have to use u and v. You could use s and t, p and d. It doesn't matter, but we like to use u and v. A lot of books use u and v. So once again, this example, we look at u as 5x squared and v as sine of x. Once again, the function could be viewed as u times v, where u is 5x squared, v is sine of x. Another example here, this would be u would be the square root of x cubed. V would be the 3x squared minus 5x plus 6. Now, it's important that you understand is that individually, if I just look at u, it'd be pretty easy to find the derivative. 5x squared, these are basic derivative rules. And then even v, if I just look at v, it'd be pretty easy to find the derivative. But the moment you take two values that are pretty easy to find the derivative and you multiply them together, now find the derivative is a little bit weirder. So let's be very, very careful with that. Now, before I go any further to show you the rule, I want to make sure you don't confuse this rule with the addition rule. The addition rule says if you have a function that is like u plus v, if you're adding two functions together. So again, if I'm looking as u and v as my two functions, if I'm adding two values together to find the derivative, you just do the derivative of u plus the derivative of v. Easy. This is a product rule. And a lot of kids think, oh, it's just like the addition rule. No, it's not. It's not. It's a little bit different. It's a lot different. So please don't think that. All right, so here is the rule. Here it is. Are you ready for it? Here it is. All right. So if you have a function that can be expressed as u times v, to find the derivative of this function, you're going to take u times the derivative of v. So you're going to leave u alone, multiplied by the derivative of v. Then you're going to take v and multiply it by the derivative of u. All right, so whatever. I was just highlighting to try to be fun. All right, but anyway, again, it's a rule that a lot of kids, you got to memorize, right? Or I don't care if you use a cheat sheet, but it's u, the first function, times the derivative of the second function, multiply those together, and then you're going to take the second function in its original form, and you're going to multiply it by the derivative of the first function. So again, remember, when you put that little prime, it means the derivative. So we have u times the derivative of v plus v times the derivative of u. Now, the order you multiply does not matter. So I could do the derivative of v times u plus the derivative of u times v. I mean, it's fine. And the order you add doesn't matter either, so you could even reverse this. But here's the one thing I tell kids. Don't ever multiply u by the derivative of u. That's not here anywhere. Don't ever multiply v by the derivative of v. It's u times the derivative of v plus v times the derivative of u, right? So you got to keep track of that. Now, here is another way that we could look at this idea of the product rule. It's the same rule. I'm not changing the rule. I'm just looking at a different viewpoint, and here it is. This is that notation I taught you guys previously. This is, hey, here's the derivative of a function. And if that, with respect to x, that's what that bottom means. So the derivative of f of x times g of x with respect to x is, again, here's the idea. It's f times the derivative of g. So once again, leave the first function alone, times it by the derivative of the second function. And then we're going to add the second function times the derivative of the first function. Second function stays the same, multiply it by the derivative of the first function. And remember, the idea is that you should be able to find the derivative of f very easily. You should be able to find the derivative of g very easily. But when you multiply them, you have to kind of mix it up a little bit, and that's the product rule. It's a really easy rule to use once you get the hang of it and you know how to use it. So let's actually start using it in the context of some problems. All right, so first off, I actually want to take a look at this problem because this is a problem that we already know how to find the derivative of. We could use the power rule combined with the constant multiplier rule. And by now, most of you that are understanding this are like, oh yeah, that's a really easy one. 4 falls down in front. 3 times 4 is 12. 4 minus 1 is my new power of 3. There's the derivative. But I want to teach you guys, now listen, that is how you find the derivative. I would recommend doing what I just did right there. But you could use the product rule because I could view this as 3 times x to the fourth. So I look at the 3 as my u and the x to the fourth as my v. Now I'm going to do this, not because I want you to, because I want you to see how the product rule works. All right, so the product rule says to find the derivative of this function, you start off with u, 3, and you multiply it by the derivative of v. The derivative of v is 4x cubed, power rule. Plus, this time in the back, you take v, x to the fourth, and you multiply it by the derivative of u. U is 3. The constant rule says the derivative of a constant is 0. But x to the fourth times 0 is 0. So this all gets wiped out. And the derivative is, voila, 12x cubed. Now, most kids are not going to find the derivative using the product rule. They're just going to use the power rule combined with the constant multiplier rule. And I recommend that. But I just wanted to walk you through how as long as you view a function as u times v, the product rule will always work, even in this problem. All right, now let's look at some problems where you definitely want to use the product rule. All right, here's that problem I started with earlier. So we have 3x plus 2, that's my u, times 4x squared minus 7, that's my v. So here I go. Let's show the product rule to find the derivative. All right, the product rule says write u, leave it alone. 3x plus 2, leave it alone. Multiply it by the derivative of v. The derivative of v is 8x minus 7. Yes, I'm your teacher. I've been doing this for years. That's how I was so fast at that. But again, remember to find the derivative, the 2 falls down in front. 4 times 2 is 8. My new power is 2 minus 1, which is 1. You don't have to write the 1, though. And then back here, the 1 falls down in front. Negative 7 times 1 is negative 7. My new power is 1 minus 1, which is 0. But again, x to the 0 is just 1, so don't even write it. Negative 7 times 1 is just negative 7. So there we go. There's u times the derivative of v. Plus, now in the back, I'm going to write v in its entirely. The normal v, 4x squared minus 7x, that's v, times the derivative of u. The derivative of u is 3. How did I get that so fast? Okay, I'm your teacher. I've been doing it for years. But again, the 1 falls down in front. 3 times 1 is 3. The new power is 1 minus 1, which is 0. So x to the 0 is 1. So that's where I got the 3 from. And then the derivative of 2, the derivative of a constant like 2 is 0. So don't even write it down. So there we go. I did u times the derivative of v plus v times the derivative of u. Now I am done finding the derivative. Now I have to do all the cleanup work. All right, I have to multiply the first part out here. So let's see how I get 24x squared Inside's a negative 21x. Well, excuse me, that's the outside. Inside's a 16x. Last is a negative 14. Back here, I have to distribute the 3, so I get 12x squared minus 21x. Then I can combine everything together for my final answer. Combining like terms, I have a 36x squared. Oh boy, negative 21, 16x, and another negative 21. Negative 21 plus 16, another negative 21 is a grand total of, let's see here, negative 21 minus 21 plus 16 is negative 26x. Sorry, it took me a minute to do that. Minus 14. That negative 14 didn't have any friends to combine with. So there is my derivative, right? Not too bad. Pretty easy. I'm going to tell you right now, you certainly would not want to use limits to find this derivative. My God, it'll take 3 sheets of paper. All right. Next problem. Here we go. So once again, I'm going to look at 5x squared as my u times sine of x is my v. So u times v. All right. The derivative, I'm going to take u, 5x squared, and I'm going to multiply by the derivative of v. The derivative of sine is cosine. Plus, now I'm going to flip that around. I'm going to take v, leave it alone, sine of x, times the derivative of u, 10x. 2 falls down. 5 times 2 is 10. New power is 1. 2 minus 1 is 1. And there I go. Now I'm going to go to clean this up. And to be honest, I can't really clean it up a whole lot. I get 5x squared times cosine of x. I guess I don't need the parentheses. Plus 10x times sine of x. Guess I don't need the parentheses. And that's it, ladies and gentlemen. Nothing more I could do there. There's my derivative. Listen, you would never in a million years want to do this problem using limits. Look how easy the product rule got my answer. All right, here's another one. Once again, I'm going to look at this as u times v. Again, product rule. Got to be multiplication. Doesn't work for addition. Doesn't work for subtraction. Got to have multiplication. Now, the one thing I am going to do real quick, just to make the power rule easier, is I'm going to rewrite u as x to the 3 halves. Once again, I have a power of 3. I got a root of 2. So I'm going to write that as 3 halves. And then this I'm just going to leave as 3x squared minus 5x plus 6. All right, now I'm ready to find the derivative. And I'm going to go ahead and use the rule. The rule says take u, x to the 3 halves, leave it alone, multiply it by the derivative of v. The derivative of v is 6x minus 5. If you're wondering how I got that so fast, the 2 falls down in front, making a 6. New power is 2 minus 1, which is 1. The 1 falls down. Negative 5 times 1 is negative 5. My new power is 0, but anything to the 0 is 1. And of course, the derivative of 6 is just 0, so don't even write it. Plus, now in the back, I'm gonna leave the part, the 3x squared. I'm gonna leave v alone. And I'm gonna multiply by the derivative of u, which again is gonna be 3 halves, falls down in front. My new power is 3 halves minus 1, which is 2 halves, and that's going to be 1 half. All right, now honestly, I mean, there's really not a whole lot you could do. Most people are actually going to probably leave it like this. You know, one thing you could do is you could go ahead and write this back as a square root of x cubed times 6x minus 5. I mean, I would not recommend distributing that. I mean, you could, but it's not fun. Now, back here, I could do this. You know, it's not going to be pretty, but, you know, I could distribute the 3 halves. I mean, if I wanted to. I mean, that's just not going to make it much prettier. So I guess, you know, you could just kind of rate the 3 halves out in front. That's the square root of x, right? X to the 1 half is the same as the square root of x. You could do that. And then 3x squared minus 5x plus 6. I mean, you could distribute the 3 halves. It's just going to make more fractions. So it's kind of an ugly answer, but, I mean, not all derivatives are pretty. I mean, come on. They're like dogs, right? I mean, not all dogs are pretty. I'm sorry if that offends you. But, yeah, there you go. So not too bad there. But sometimes there's just not a whole lot you could do with your answer. It just kind of is what it is. All right, let's do one more here. Now, I really want to make sure you understand that the product rule can only be used when there is a product. So I don't want you to forget about the other rules we've learned, right? We have learned the addition and subtraction rules. And listen, the addition and subtraction rules, they're rules, but they're so simple. It's if you are subtracting two things, you find the derivatives of each. Done. If you're adding two things, you find the derivatives of each. You're done. The product rule does not work like that. So this is a more complicated problem because I have a product, 2x times cosine, a u times v, minus that subtraction, 2 sine of x. So remember, the derivative rule with subtraction basically says, hey, find the derivative of the first part minus the derivative of the second part. That's it. But here's the hitch. To find the derivative of the first part, I need the product rule. So what I'm going to do right now is I'm going to find the derivative of the first part. And again, I'm going to need the product rule for that. So I'm going to take u, 2x, multiplied by the derivative of v, negative sine of x is the derivative of cosine. And then I'm going to add. Now I'm going to flip that around. Now I'm going to take cosine of x, that's v. I'm going to times it by the derivative of u, which is just 2. The derivative of 2x is just 2. Hopefully you know that. So that right there, ladies and gentlemen, is the derivative of the first part. And then the subtraction rule says, okay, then subtract the derivative of the back. Well, the derivative of the back is just 2 times negative well, not negative. What am I doing? The derivative of sine is cosine of x. Now, I did not need the product rule back there because I could just, at this point, choose just a constant. The constant multiplier rule says if you have a constant, just leave it. So negative 2, and then the derivative of sine is cosine. But listen, some kids will get the product rule so ingrained in their heads and that they will actually treat this as 2 being u and sine being v. Okay, watch what happens if I do that. You're going to get 2 times the derivative of sine, which is cosine. And then you're going to do plus, and then you're going to do v, sine of x, times the derivative of 2. But the derivative of a single number 2 is 0. So this all gets wiped out, and you get 2 cosine of x. So again, you don't need the product rule in that situation because 2 is just a constant. So you just use the constant multiplier rule. But anyway, let me go ahead and clean up this entire thing. Let's see here. This becomes negative 2x sine of x. This becomes 2 cosine of x. And then back, ooh, check this out. Back here I get minus 2 cosine of x. And those, my friends, are going to cancel. Those are just going to make a 0. So at the end of the day, I get a pretty simple derivative. Negative 2x sine of x is my derivative. So be careful on problems where you have to combine the product rule with the addition or subtraction rule. So you got to remember that the addition subtraction rule basically just cuts you off. Find the addition of the first plus the addition of the back. Easy. There's no real rule there, even though there kind of is. It's just simple. But the product rule is like, no. The product rule is not that simple. You know, let me kind of show you what I mean by this. I will get a lot of kids that think that they don't study, they don't listen, they don't pay attention, however you want to say it. And they think that the product rule says, oh, if I want to find the derivative of a u times a v, oh, the derivative is the derivative of u times the derivative of v. Done. No, not true at all. But for addition and subtraction, that is true. So I see why you make that mistake, right? The addition rule says if you got u plus v, well, the derivative is the derivative of u plus the derivative of v. Done. Easy. The product rule is just not that simple. Sorry, folks. The product rule for u times v is u times the derivative of v, v prime, plus v times the derivative of u, u prime. There you go. So you got to be super careful because when you have a product, the derivative actually splits that up with addition. Crazy, right? Okay. So make sure you know how to use the rule. Make sure you know when to use the rule. Pretty cool rule, pretty easy rule to use. Love you guys. See you later.